Okay, so now we have our second warm-up problem here with solving systems of equation by substitution. We still have the same goal of trying to find the x value and the y value that works in both of the equations. In other words, the intersection point between these two lines. The problem with this one is that neither one of the equations is in x equals or y equals form. Recall that for solving by substitution, really we need one of the equations to be in either x equals or y equals form so that we can plug it in, substitute it in to the other equation. So we're going to have to change one of these equations into x equals or y equals form. It will work with either one, but one of them is probably easier to change into x equals or y equals form. If you take a look at the second equation over here, the second equation, x minus negative 3. It would be easier to change that equation than the first equation because we really already have an x sort of by itself. We just need to move that minus 3y over to the other side, and then we'll have an x equals equation. So what we're going to do is we're going to change that equation. So we're going to undo the minus 3y by adding 3y to both sides of the equation, which cancels out the minus 3y on the left-hand side. And then we have a new equation that will be x equals negative 3 plus 3y. Remember, they're not like terms, so we can't combine the negative 3 and the positive 3y. We just keep them separate. So now we really have two equations again. We've got our x equals negative 3 plus 3y. That's the new transformed equation. And then let's just rewrite that first equation, which is 2x plus 2y equals 10. Okay, so now we're at the same point as we were with the other solving by substitution problems. We have to look at what x equals. Notice it's an x equals equation. So I want to circle what x is equal to here. X is equal to negative 3 plus 3y, and I want you guys to circle it as well. And then we're going to plug it into the second equation, but be careful, this one's an x equals equation, so that means it's going to go in place of the x value. So I want you to draw an arrow to that x value in the second equation, or in the 2x plus 2y equals 10 equation. And now let's rewrite the equation with that substitution. So now we have 2, instead of 2x, we have 2 times negative 3 plus 3y in parentheses there, and then we'll rewrite the rest of the equation, plus 2y equals 10. So now notice that our new equation after the substitution only has y values in it. We no longer have x values in it. So now we can actually solve for y and then eventually plug it back in and solve for x. So recall the next thing that we have to do is use our distributive property. So we're going to multiply that 2 times the negative 3 and also multiply the 2 times the positive 3y. So we're going to multiply both of the terms by the 2. See, I've run out of room down at the bottom here, so we're going to continue this problem up top. Over here, so 2 times negative 3 is negative 6. And then 2 times positive 3y is going to be positive 6y plus 2y equals 10. Okay, recall the next thing that we're going to have to do is combine like terms. So hopefully you're seeing the positive 6y and the positive 2y. Those two are going to combine together since they're both positive. We just add them and we get a total of 8y after combining those. So rewriting the equation again, we have negative 6 plus 8y equals 10. Okay, so now we are at our two-step solving equation process here. So at that point, I like to draw a little line down the equal sign like I've done before. And we have to get y by itself. Recall that we have to work our way back to the y, starting with what's farthest away and undoing that first. So in this case, we have to undo the minus 6 by adding 6 to both sides of the equal sign. That cancels out the minus 6. So now we've got a positive 8y equals 10 plus 6 is 16. Then, since we use y, we're going to undo that multiplication to get y by itself by dividing both sides by 8. 8 divided by 8 is 1, so that cancels out the 8s, and so we're left with 1y or just y. And then on the other side of the equation, we have 16 divided by 8, which is 2. So y equals 2. Again, recall that's really just half of the solution. We still need to get what the x value is equal to. So we're kind of drawing a lot of lines on our paper here, but notice that our equation back over at the beginning here, after we transformed it, after we solved for x, is going to probably be the easier one to plug it into. But you can plug it into any of the equations back at the beginning here. But what I think we're going to plug it back into is the one that already is set up as x equals. So you can plug it into any of them, but we're going to plug it into that one. Okay? So organizing our work a little bit here. Now we've got x equals negative 3 plus 3y. That's our equation. And we're going to plug in the value of 2 for y. So x equals negative 3 plus 3 times 2. So y value is 2. Now we're just going to use order of operations. We have to remember to multiply before we add. So we have to multiply the 3 times the 2, and that's 6. So negative 3 plus 6, and negative 3 plus 6 is positive 3. So our other half of our solution is x equals 3. And as I told you before, why don't we go ahead and rewrite the final answer as a coordinate points. So with coordinate x value of 3, y value of 2, that is the place at which these two lines are going to intersect. That is our solution to the problem.